Here is another profile cut through a branch of a peripheral nerve. These little dark dots are the axons of nerve fibres. This section cuts transversely through a muscle spindle here. Muscle spindles are a part of the proprioceptive system, supplying sensory information to the nervous system concerning how extended or stretched the muscle is. As you can see, they lie amongst the muscle fascicles and can be about 2 millimeters long and about 100 micrometers wide. Don't mistake the section of the nerve bundle, tiny artery or vein running nearby in the perimysium, for the muscle spindle. Now, the perimysium forms a capsule around the muscle spindle, usually layers of flat cells containing interstitial fluid. A muscle spindle includes a few almost vestigial skeletal muscle fibers as well as a complex of nerve endings wrapped up in this connective tissue sheath. Muscle spindles are spindle-shaped. That's no surprise, but sometimes they bifurcate at the ends, and for this reason, this image shows at least 3 sections individually surrounded by the perimysium sheath. The red circles inside are intrafusal skeletal muscle fibers. See their peripheral nuclei? They're much smaller than the regular extrafusal fibers of skeletal muscle outside of the spindle here. And over here, you can see an axon of a sensory nerve. It's this little round dark spot. This white space around the axon is where the myelin sheath would normally be, but it's been extracted during histological processing of the tissue. A number of sensory nerve axons will penetrate the muscle spindle and envelop an intrafusal fiber. And when changes in length of surrounding extrafusal fibers occurs, this distension is sensed by the muscle spindles, and the sensory nerve axons relay that information to the spinal cord. Many different types of both the sensory nerve fibers and the intrafusal muscle fibers monitor the complex movements of our body to help maintain our posture and our motor activities. Golgi tendon organs are much smaller, and they're located in the collagen bundles at myotendinous junctions, and they detect tension in the tendon produced by muscle contraction. If the tension becomes really excessive, then they inhibit motor nerve activity to the muscle. This is an image of a musculo-tendinous junction. You can make out skeletal muscle fibers with striations. The endomysium, perimysium, and epimysium will become continuous with the dense regular connective tissue of the tendon. This then imparts a force of contraction of the muscle onto the bone and effects movements across a joint.